Hey everybody, really glad to be here. So I'm going to start today with a little bit of tough love. These are statistics from September on application layer attacks. And I always like to start out my talks with this to give people a real feel for what application security really looks like. You can see your chances of getting attacked with path traversal or SQL injection or XSS are better than half. The number of applications that were not attacked, and this is across tens of thousands of applications that we monitor, your chance of any one application being attacked is 100%. We saw no applications that weren't attacked in September, and it's pretty much the same every month. So this is a little grim. That's quite a lot of attack traffic across a lot of different categories of attacks. And we've been trying to do something about the vulnerability side of the equation for a long time. Back in the early 2000s, I was doing a lot of pen testing and code review. I started a consulting company called Aspect Security, and we averaged about 26.7 vulnerabilities per app. Shortly thereafter, I wrote the first version of the OWASP Top 10, and it captured those vulnerabilities. Today, average number of vulnerabilities per app is almost exactly the same, 26.7 vulnerabilities per app. That is a terrifying number. If you were building airplanes, and every time you did a safety check, you came up with 26.7 safety problems in an airplane, you'd never fly. But we trust applications almost without any reason to trust them. Who here banks online? Okay, I see a bunch of hands. The rest of you are liars. How much do you really know about the application that you're using to do your online banking, that you've trusted with your money? Do you know who wrote it, or how they were trained, or what libraries they used, or what security mechanisms are there, or how they tested it, what tools they used to test it? What do you know? You don't know anything about that thing, but you trust it with all your money. And you trust web applications with your healthcare, your government, your defense, and your social whatever. Almost everything is on the web these days, and we're trusting these applications that we have no reason to trust. The evidence is pretty clear that the web applications and web APIs are not tremendously secure. In fact, we stink at writing web apps. I helped to start OWASP in 2001, 2002, and we were struggling with the same problems. But now it's been, it's coming up on 20 years, and nothing's changed. And so I wanted to give a little bit of history into this problem. Way back in the early 80s, government was working on government security standards. They were wrestling with these same problems. If you look at the Orange Book, they're looking at the problem of how do we generate assurance in the systems that we're building. My first job was with a Navy contract where we built a high assurance system for the US Navy. And we started with a formal model of what security was supposed to look like. We had traceability to requirements and a top level spec and a detailed spec, all the way through to test cases. And we don't have anywhere near that level of assurance today in the systems that we're building. So in a lot of ways, things are going backwards. Then over the years, I worked on a number of different things. I worked on something called the System Security Engineering, CMM, which was a maturity model for helping to build secure systems. Didn't change shit. Keep going forward. I wrote the OWASP Top 10, 2002. Got a lot of awareness. Didn't change a damn thing. OWASP Top 10 today still has the same stuff in it that was in it in 2002, basically. Been through pen testing and code review and static analysis and WAFs and BSIM and OpenSAM, things like that. Now we're moving into DevSecOps. Okay, great. I'm not super optimistic. I love DevOps and I like the idea of DevSecOps, but I'm not super optimistic about whether we're going to make a change because nothing has changed. Really, I blame what I call tool soup. We don't have enough resources to do the job of application security manually. I love manual code review and pen testing. I actually really like code review. I'm weird that way. But I find it super effective at finding really critical vulnerabilities. But it doesn't scale at all. So we've got to automate. If we want to get out of this problem, we've got to automate it. There's no other way possible. There's something like 21 million developers in the world all writing code, and a tiny handful of security folks that are actually working on securing that code. We'll never get that fixed. But we use all these kinds of tools, and to run a modern AppSec program, you kind of have to do all these things, right? You got to run SES, and you got to do test, you got to do pen testing, you got to do code review, you got to run software composition analysis, you got to do fuzzing, you got to do WAFs and NG-WAFs and IPS and so on. No organization can effectively run all these tools because they're all disconnected, and frankly, they all have a ton of errors. Anybody have false positives in their security scan results? Yeah, they're super frustrating. You probably also have a ton of false negatives that you just can't see because a false negative is not something that shows up in your face. It's just not found. So these tools make errors on both sides of false positives and false negatives because they don't have complete information. Static tools can only see the source code. That's like one weird lens of looking at an application. Dynamic tools can only see HTTP traffic, so they get a different view of the application. Very different, in fact. I think you'll find your static tools and your dynamic tools are finding totally different stuff. Library analysis tools or SCA tools, they can only see the libraries. They can't see anything else of how this application works. So you don't know if those vulnerabilities are real. All these tools have a different view of the application. That's why they make so many mistakes. And because they make so many mistakes, we have to have experts involved because only experts can really resolve those problems. And if you have experts involved, guess what? You can't scale because there's not enough experts. So we're fundamentally stuck. I call this, I want to look at one other thing quick. So I want you to think about the cost in your organization to assess one application. And your numbers might vary slightly. But if you're going to run SAST and DAST and SCA, you're going to have a significant amount of cost. Every time you run a scan, there's going to be a bunch of work to run the scan and a bunch of work to triage it, and if you want to count the work to remediate those vulnerabilities, you can count that. But there's a ton of work, and not just license cost of a tool, but the cost to run that thing is 80% of the cost of that. And so look, if you're doing scans once a year, you're going to have one big bump of cost when you run that scan for that app. If you're doing scans every month, you're going to have a different model. It's slightly less work because hopefully you'll get a little bit more efficient at it, but you're going to add up cost. And if you're doing weekly scans, I don't really know anybody who's doing daily scans effectively because the cost is too much. You couldn't possibly triage all the output from those tools that fast. But the cost goes up as you increase the velocity of software. And guess what? Everybody's increasing the velocity of software. We're rolling, I work for a DevOps organization. We do 6 or 7 releases a day. So, we don't have the time to run those tools as part of our standard pipeline. So we're kind of stuck, and the outcomes that we're generating are really ridiculously weak. And I want you to focus on the outcomes of AppSec, because focusing on the processes just means you're doing a whole bunch of stuff, right? And you guys are probably doing training and requirements and architecture reviews and pen testing, code review, all these activities. But what really matters is the outcomes. And here's how I visualize it. So on the left dimension is your application inventory. I usually think at organization scale, because anybody can come in and do some work on one application and go home and feel good, like, oh, I found some vulnerabilities. I made the world a better place today. But I want you to focus on the whole portfolio, because most organizations are only looking at a small subset of their portfolio. Anybody's organization prioritize their portfolio, like you've got the critical apps and then a bunch of others that never get looked at? Most organizations are only looking at like 10% of their portfolio. I was talking to a major financial organization, CISO on Wall Street, and I asked him about that. He said, well, we're doing about 10%. I was like, well, what about the other 90? He goes, well, they're one click away from the Wall Street Journal. That's the risk. So I feel like we really need to look at the whole portfolio at some level. All of those applications are a potential gateway into your enterprise. And a lot of the breaches that we've read about, Target and so on, they're not through the critical apps. They're through some little web application that gets compromised and becomes a gateway into your enterprise. So on the left is like, how much of the portfolio are you covering? And on the bottom is, have you covered all the vulnerabilities that you can find in dev? And then in production, what are you doing in production to make sure that you can see who's attacking you and prevent them from exploiting you? There's a lot of talk about DevOps and DevSecOps, and almost all of it just focuses on dev. People talk about shift left. That's weird to me, because we definitely need to shift left, but organizations need to shift right as well, or extend right. Because in operations, that's where you can see attacks and prevent attacks. And we're really weak there. So when I look at what most organizations are doing, I see some manual pen testing and code review on the critical apps, and then some automated scanning of some percentage of the portfolio. You can draw your box as big as it should be, but those scans are pretty weak, and the pen tests don't get applied very broadly, and frankly, they test for the same stuff, because they're not accurate, right? You run a scan for I don't know, SQL injection or something, but then you need to come back and do a pen test for SQL injection 2, because your scans weren't really very accurate. So we're wasting effort up here because we're duplicating stuff, and then there's a ton of space that's just missed. These are the outcomes that we're generating. This whole thing should be green. That's really the outcome that you want to generate, is green. All your vulnerabilities are detected in dev across your portfolio, and in production you've got protection against all those applications being exploited. And you might say, well, Jeff, why do we have to do both of those things? If I'm creating secure code, who cares in production? Like, why do I need to identify attackers? I'm secure already. And maybe vice versa. You might say, hey, if I'm protected against being exploited in production, maybe I'll just write code however the hell I want. But that's not how the real world works. It's important for a number of reasons to do both of these things. And there are a number of scenarios where you just can't respond back fast enough. And library vulnerabilities are a good example. Anybody got insecure libraries in any of their apps? That is the simplest problem in AppSec. It was actually very controversial when I added that to the OS Top 10. But it seems like the simplest thing in the world. Don't use libraries that have known vulnerabilities in them. Like, don't use a gas tank in your car that explodes instantly. Yeah. Well, keeping that open source up to date and using versions of libraries that don't have vulnerabilities should be the easiest thing in the world. It's a lot easier than some of the other problems we have to tackle in AppSec. But it's still a challenge for a lot of organizations. So when I zoom out on this problem, I think the economics are broken. And I want you to think about this, not just for your own organization, but for the world in general. Like, we are building code at an incredible rate, and it's far outstripping the ability, our security abilities. And until we fix these economics, nothing's going to get better. We've got to do something dramatic to change these economics, or we're cooked. And things are just going to stay the way they are for another 20 years. So I have this idea that what we're really trying to do in a lot of our activities, like all the things that we do in the SDLC and all the testing and scanning, all the things we do, eventually we have to get development to do something, right? We got to get them to change the code somehow, to either take out vulnerabilities or put in security controls or whatever. So we're trying to take all this stuff that we do to influence development to make the code more secure, right? And it's not really working. We're only getting a tiny percentage of what we want actually into production. I would love to see applications that have some assurance. Like before I use a web application, I'd love to know, hey, how was this thing tested? Why should I trust you, my investment advisor? Why should I trust your online application? I'd like some evidence about that, but we don't have it today. And we're not going to get it because we're trying to make development do all these things that, frankly, they're not really inclined to do. So there's a lot of talk in the DevSecOps community about security as code. Anybody heard that? Yeah, the idea is that we take the things that we do in security, in AppSec specifically, and turn them into code so that we can run them at some point, either part of our pipeline or part of the application, and automate them effectively. And when I think about it, there's development that's working on business code, they're working on functions and features that are part of the app, and then there's security code that we want to run. And some of that security code is defenses, some of that security code is testing code, and some of that is monitoring in production. That's code that we need to get into the application, into our software. But we're trying to take that code and we're trying to push it in development or make development do it, and it hasn't ever been very effective. So it occurred to me, what if there was a way that we could get that security code into production without going through development? A different path for getting that security code into our apps. It's worth thinking about, right? Because we're pretty terrible at it's not working the way we're doing it. So maybe there's an alternative idea. So I want to tell you about security instrumentation. And I'm going to use a pen testing example to start, and then we'll get into the details of instrumentation. You guys know how to pen test, right? Someone once described pen testing to me as looking up the shower head to find a problem in the water heater. And it's like that. You've got your tools, maybe you're using Zap or Burp or something, and you're pen testing web application. You're trying to see if there's vulnerabilities in there. And all you can see is the request that you send to the app and the response that comes back from that application. And sometimes it's going to come back with a 500 error, sometimes it's going to come back with a stack trace, sometimes you're going to actually get a vulnerability and you'll see something in your browser like, you steal the data out of the database, whatever. But often it's very difficult to tell even if you found a vulnerability. And you got to poke around forever to do it. So this problem doesn't really scale very well. It requires experts, it's not super accurate, and doesn't generate great coverage, and it's slow. So I want you to imagine how that changes if you can get an agent inside the application. Like imagine you had a buddy that was inside the application as it's running, that could observe what you're doing from inside the application. So if you're thinking in the real world, like if you're a pen tester of a bank and you're throwing rocks at the outside of the bank and you're trying to hit the safe, it would really help if you had someone inside the bank to watch where your rocks were going, tell you what the reaction is, and so on. So imagine if you had someone inside, you wouldn't even really need to do security testing. You could just use the application normally. And you could see what's going on inside the application. You could see where things are misconfigured. You could see where SQL queries aren't properly parameterized. You could see where tokens aren't used to protect transactions and so on. So for example, you could see if a query was taking untrusted data and putting it into the query without escaping it or parameterizing it, you could just see that and report it back. So you wouldn't have to be an expert tester, you could just be a normal developer. And you could get all the details of that vulnerability back from your buddy inside the application. He could send you, hey, on this exact line of code with these parameters, this stack trace, all the details of that vulnerability. This URL, this HTTP request, all that stuff could come back. The same thing for weak encryption algorithms and other things. So this idea of getting inside the application is really powerful. It's kind of what we're trying to do when we're doing pen testing and code review at the same time. You're trying to imagine what's going on inside the application. But what if we could just be there? So I want to talk about instrumentation. Generally, instrumentation is the idea of adding measuring devices to a complex system. And we instrument complex things in our world. We instrument cars and airplanes and factories and space shuttles like crazy because they're super complicated and there's no other way to know what's going inside them. But software, which is arguably the most complex thing man has ever created, has terrible instrumentation. Log files give you almost no visibility to what's going on inside a running application. That's nuts. So this whole talk is about how we can use instrumentation to get better visibility inside the software that we're running, and I think it's really the key to doing application security better. My first experiments in instrumentation were I was back in 2009 or so, and I wrote an instrumented version of the MySQL driver in Java. And this is an example. All I did was I just added some code to simply tell me when people were using non-parameterized queries. And I recompiled the driver, deployed it with any application you want. I was using WebGoat or something. But when you deploy with this driver, all of a sudden you just use the application normally and you get a detailed list of every single query that's that's not properly parameterized. Now, not all of these were vulnerable, but they might be against your standard. But these are all, it's interesting, and you can get a ton of information. You can get the full stack trace, you can get the HTTP request that caused this to happen, you can get the currently logged in user, you can get a ton of stuff just by instrumenting a driver like this. And I thought, kind of a light switch flipped on. I was like, wow, this is fantastic. I just want to instrument my app to get the information I need so that I don't have to waste so much damn time code reviewing and pen testing. And so I started heading down that road, and I discovered there are libraries that allow you to do this. So binary instrumentation has been around for a long time. Instead of instrumenting the source code, which requires you to recompile things and redeploy things, you can instrument the binaries directly. So it's just sort of a one-time translation. And here's an example of that. In this case, I use ASM a lot. I use JavaSys in the beginning. But you can add the same kind of code to your application just by analyzing the binary. And then you don't have to recompile. You can just run everything through one big compile step. And there's a ton of libraries to this. This is the exact technique that tools like AppDynamics and New Relic use for performance. Security is really late to this party, by the way, doing instrumentation for security purposes. And then the last step here, so we did source code instrumentation, we did binary instrumentation, but the last step here is doing dynamic binary instrumentation. And this is actually really easy. There are APIs, like there's the Java instrumentation API, I'm going to show you in a second. There's also the .NET Profiler API. There's various approaches to this in different languages. But the whole idea here is you can hook the loading process so that as the code loads from disk into memory, you can hook that process and add sensors to that code. You can actually do whatever you want to that code. But I think it's safest to just add passive sensors that allow you to observe the application as it runs. And then as that code is being used, it can send interesting data to some analysis engine that will allow you to identify patterns of code behavior that you don't want to see. So for example, if you wanted to see SQL injection, you might look for untrusted data coming from a call, like request.getParameter, then flowing through the application and being added to a query without being properly escaped or parameterized. You could see that whole pattern using instrumentation. And so your application could almost tell you where the vulnerabilities are as it's running. This is a really powerful way of thinking about AppSec. And because it's inside the running application, it's much more accurate. It's got a ton of context. So instead of having, a separate static analysis tool and a dynamic analysis tool and a software composition analysis tool, imagine you could take all those, shove them down into a small instrumentation agent, and deploy them as part of the application. Okay, so this is a powerful concept. This is how the Java instrumentation API works. You write a little jar file, in this case called agent.jar, and when you run Java, you just add that flag. That's a standard Java deployment option. And what that does is it registers this transformation engine with the class loader. So that now all the classes, as they're loaded, they go through the class loader. You've registered this transformer. You transform the bytes in that class file, and then that is what actually gets loaded, and then you end up running in production with instrumented bytecode. So this is really cool. I don't have to make any changes to the way that all my source code. I don't have to change anything about the way I build, test, or deploy my application. I can just add this flag, and I get an instrumented application that is now just telling me tons of security information about what's going on inside the running application. Okay? So this is my little buddy that's helping me inside the running application. It's going to help me with security. So what can we do with that? Well, my first experiment was 10 years ago. And in the intervening 10 years, there's been a lot of progress in this space. So I want to take a minute and tell you about the three technologies that are using this today, and then we'll talk about what is possible tomorrow. The first is IAST. Anybody heard of interactive application security testing? Okay, so IAST uses this technique to get inside the application and find vulnerabilities. And it's got a number of advantages. When you deploy IAST, it runs in the background and analyzes your application while you do your normal work. So developers don't have to change anything about how they do their job, and they don't need any security expertise. Because when IAST reports a vulnerability, it reports exactly what it observed in the running application. So it's got that huge advantage in terms of accuracy. And IAST runs in real time. So as you're developing and testing your application, it can just give you instant feedback on the application, and developers can fix it in real time and check in clean code. Now notice how different that is. That fundamentally changes the economics of application security. If developers can just get accurate security information as they're coding, they can fix it and check in clean code. You notice there was no security expert in that loop? You don't need a security expert to run that tool. You don't need a security expert to triage the results. You can just fix it and check in clean. So that's how we can leverage the big machinery of software development to do the work that has to get done by using better security technologies. Another thing that instrumentation can do is it can do that library analysis. So instrumentation can see all the libraries that are in use in your application, and the actual ones, not the ones that are listed in the POM, not the ones that are in your repo, but the ones that actually get loaded at runtime in your application, which are often different. If your application does dependency injection, or it's loading plugins, or a variety of other things, you could end up with code that's very different than what it looks like if you're just looking at a source code repo or something. So dynamic software composition analysis analyzes how you use libraries at runtime. And probably the most important thing that it can do is it can tell you exactly how you're using those libraries. It turns out in Java applications, 72% of the libraries are never invoked. That hopefully surprises some of you, because if your tool is just scanning the repo and saying, hey, you've got 15 libraries that are out of date or have known vulnerabilities, you probably want to know which of those really needs to be replaced and which one is just along for the ride because it's a dependency of some other dependency of some other dependency that never gets called. So Dynamic SCA has that advantage, and it can cut out a ton of the work associated with keeping libraries up to date. And then the last thing is called RASP, or Runtime Application Self-Protection. And while the first two things are things that you might use in development, RASP is something you use in production. And it uses this instrumentation-based technique to not identify vulnerabilities, but to identify attacks against those vulnerabilities. So just to be totally clear for everyone in the room, like a vulnerability to me is like an open window. An attack is somebody crawling through that window and stealing your stuff. And so they're very related, right? It's the same, almost the same kind of thing. Attacks, you actually get a little bit more information because there's someone trying to exploit that problem. So RASP can actually see that exploit as it's happening in context, inside the code. So I want you to imagine a SQL injection attack. Attacker sends in single tick or 1 = 1. That data flows through the app, ends up in a SQL query, and RASP can actually see that whole query, and analyze and say, hey, that attacker's data actually changed the semantics of that query. That's the definition of SQL injection. And that's when RASP intervenes and prevents that attack from going to the database. So this is very different than like a WAF or something that sits in front of your application and can only see HTTP traffic. If you can only see HTTP, it's really impossible to tell whether something is actually an attack or not. In fact, every HTTP request these days looks like both SQL injection and cross-site scripting, because it's all full of JSON and single ticks and equal signs and so on. So it gets really complicated to tell whether it's actually an attack or not. But RASP can see how that data is used. WAFs don't really know what they're protecting, so they make tons of mistakes. RASP, on the other hand, is in the transaction itself, and so it can tell whether it's a real attack attempt or not. So I want to just give a graphical description of how IAST and RASP works so you can understand. So the first thing that happens when your application starts up, the instrumentation adds a bunch of different kinds of sensors to the app. These sensors allow the application to see the HTTP traffic, to see the code, to see the data flow, see the libraries, and so on. And then as you use the application, like let's say you're just a developer and you're testing your application, you don't have to exploit it. I could just type in the word Jeff into a form field. And that word Jeff, maybe it's in a header or in a form or something, that word Jeff would flow through the application. Maybe it gets added to some other data or substringed or transformed in some way. But eventually, that data would make it to some sink. Maybe it's command, like runtime.exec, maybe it's parsing an XML document, maybe it's evaluating an expression, whatever it is. There's a million of different ways that could be a problem. But at the end, this IAST can look back at that path and say, hey, I know data can flow through this path because I watched data flow through this path. And it can say, and I know that path didn't have the right security controls on it. And that's the definition of those vulnerabilities, right? If we see that data flow through and it didn't go through the right controls, then we know it's exploitable. And so we get a confirmed vulnerability. That's very different than a scanner tool that can just sort of suggest, well, there's a vulnerability that's possible. And RASP works almost the same way. So imagine that same thing, but now with an attack in it. And I did this before. The data flows through, ends up in the query, and we can see that attack actually changed the semantics of the query. And so then we can intervene. Typically what RASP tools do is they throw an exception, just like as if that query had failed somehow, like maybe the query timed out or something. We can throw a security exception that says, hey, that SQL query is no good. It's about to get exploited. We can prevent it from exploiting our applications. So that's the thing. Getting inside the application makes AppSec more accurate. And being more accurate means you don't have to have security experts, and getting the security experts out of the loop, and this may be hard for some of you if you're security experts, but getting you out of the loop is the only way that we're going to change the economics of application security. And that was a tough realization for me after years consulting in this space, realizing that I'm the problem. So we've got to become toolsmiths and coaches rather than the last line of defense against SQL injection and cross-site scripting and so on. Okay, so that was all for one application, right? That's how I think about securing one app. But it's really important to think at portfolio scale. So I want to zoom out. I want you to imagine instrumenting a whole portfolio of applications. So that little box represents our instrumentation agent, right? That's our buddy on the inside. We're going to take that agent and we're going to make it part of our standard app server build. Whether we're deploying in cloud or containers or VMs or in a data center or I don't care how, add that agent to that platform so that it's in development environments, in your CI/CD environment, in your production environments. That agent's now observing the application and detecting both vulnerabilities, library problems, and attacks. And as you do your normal job, your normal development process, building code, testing code, deploying code, the agent's there, and it's reporting that telemetry to some console, somewhere. So you've got visibility into a portfolio of applications in real time. Now think how different that is. Normally, AppSec teams go app by app. They test one, move on to the next one, test another one. Maybe they do a couple in parallel, but it's not, it's basically a serial operation. And then, depending on how far you want to go, maybe you go all the way through the criticals. Nobody really goes all the way to the end of the portfolio. But then you cycle around and you start over again. You do the same thing again. And it ends up being pretty painful. But imagine if all those applications are essentially testing themselves, and you've got up-to-date information on every application in your portfolio. You know where all the vulnerabilities are, you know all the libraries that aren't up to date and have known vulnerabilities, and you see attack traffic, and you know who's attacking you, what kind of attack techniques they're using, you know which systems they're targeting, and you've prevented those attacks from exploiting you. You can take that data and feed it back into the development teams. So that's this feedback loop. You want to take this information and get it to the people that need it through the tools they're already using. And the cool thing about instrumentation is that this whole feedback loop takes about 1 second. So as soon as a developer makes an error, they test their code, it gets detected, they get alerted through whatever means they want, like you could give them a Slack alert or a Jira ticket or an email message or however they work. You can give it to them right through their IDE. They can get an alert, they can fix it, and check in clean code. This is a very different way of thinking about AppSec than having a team of people that tests a ton of applications, piles up a pile of vulnerabilities, and never gets anything fixed. I know a number of organizations that have risk registers or bug trackers that have 30,000, 40,000 vulnerabilities in them that they're not fixing. Because that's how the process that we're using for AppSec today, that's what it does, is it generates a big pile of vulnerabilities that don't get fixed, and we're not improving the situation at all. This way we can actually improve the situation. So we'll talk a little bit about how instrumentation affects the SDLC. So in development, the goal is to get developers to commit secure code. Right? That'd be great. If the developers were all producing secure code on their own, then there wouldn't be a ton of downstream work to do. So that's our goal here, is we want to empower developers to write and commit secure code without pissing them off. And just a brief aside here. I know I did a lot of pen testing for a lot of years, and I was really proud of the work that I did. But frankly, when you deliver it to development teams, you're delivering a turd. And you're proud of it. Like my child, when he was little, he was super proud of what he had produced. But it's not viewed that way by development teams. You're walking in with a present for the development teams, and then that's just work for them that they have to go fix. So this is a way of supporting developers and doing their own security. Then they don't have to get beat up. In QA, we get different goals for security. Here, we want to make sure that everything's been thoroughly tested. People talk about shifting left. Mostly when people talk about shifting left, they're talking about taking expert security tools and pushing them down on development teams that aren't trained or qualified to use those tools. That's shitting left. What we want to do here is we want to make sure that we keep that testing before we go into production, so we have assurance. And if you remember, back in the 80s when I was working on a highly secure project, our goal was to build high assurance systems. Ultimately, that's what we need to get back to. That's what we can do in QA here. With using instrumentation, we run our normal QA tests, we get assurance that everything was tested and that it's safe to go into production. And then in operations, again, we want to know about who's attacking us, what kind of attacks they're using, and prevent those attacks from exploiting us. So those are kind of the goals of each of these activities. And I want to show you how we can build a pipeline that supports those goals. So this is a simple pipeline for a Spring Pet Clinic. If you're interested in this, I've got a video online that shows exactly how to build this whole thing. But you can clone the Pet Clinic repo, and you can build it and push it into deployment using this pipeline. the first step to getting security done here is to add an instrumentation agent to the development environment. And that it sits in the background, it does its job, it finds vulnerabilities as the developers are building this app, and it reports them through Eclipse and Slack and so on, and gives them instant feedback on the code that they're writing so that they can commit it clean. In QA, we've got the same instrumentation agent. Now, it's running on the test server. So as you do your automated test, as you do your manual test, that agent is in the background looking for vulnerabilities. We also want to run our RASP here in the test environment. Anybody know why we want to put our RASP agent in our test environment? I mean, nobody's going to be attacking test, right? Say again? Why not? Well, why not is a good point. Actually, the point of this is to give everybody confidence that the application works with full blocking turned on, right? You can't really do this with a WAF because it's so painful to set up, but with RASP, you can easily add this to your application environment, and you can get instant confirmation that your application works with security all enabled. And then in operations, that's when you can go with just RASP, right? You just turn on RASP. You don't need to run IaaS there. You don't want to discover vulnerabilities in production. You want to discover vulnerabilities in dev. Unless you've got a bunch of legacy apps out there that nobody's got a dev environment for. They're just running. You can add IaaS there and get feedback on libraries and vulnerabilities, and then you can decide what to do about them. So this kind of pipeline, notice that this doesn't make any changes to the way this team builds or tests or deploys their code. It's like a security layer that adds on top of this pipeline. And it's easy. You can do this in 30 minutes. So instrumentation is not just limited to AppSec. I've been talking all about IAST and RASP, which are kind of instrumentation at the application layer. But I want you to compare this to how we used to do security with scanning and firewalls, which are kind of outside in and super noisy because they're far away from the actual code, the actual running application. Today, we can do security instrumentation that attaches directly to the layer of the stack that we're interested in. So at the application layer, that's IaaS and RASP. But at other layers, like the container layer, you may want to add an instrumentation technology there, something like Aqua or Twistlock. At the operating system layer, maybe you need to use a product that gets inside the application, like Carbon Black or something. In the cloud, maybe you've got something like ThreatStack that's directly monitoring that layer. And this, when you put it all together, you can see this is a fundamentally different approach to security than trying to do these outside-in, perimeter-based kind of approaches. And I think that's the transformation that we're seeing in the market. As people move to cloud, as people move to DevOps, all of a sudden everything's software-driven. The advantage of doing this scanning and firewall-based approach is that you can centralize security in one place. That used to be the easy way of doing things. We'll just put a firewall there, we'll create a perimeter, and we can control security from that one point. Anybody think that works anymore? No. So we can do this distributed approach to security. If you get a chance, there's a guy named Ed Amoroso, he used to be the CISO of AT&T. He talks about this paradigm where he says what we need to do is explode, which means blow up your monoliths, move them to the cloud. The moving to the cloud part, that's offloading, so take your workloads, split them up, move it to the cloud. And then he says reload, which means take technologies like this and instrument the application, those workloads for security. So you've got now, instead of having one big perimeter, now you've got a whole bunch of stacks out there that are all defended using an instrumentation technique. And he makes a comparison to a botnet. He's like, we should control our application security like we own the botnet. And your own infrastructure becomes that command and control system. So what's next? We are just scratching the surface of what we can do with security instrumentation. I talked about IAST and DSCA and RASP, but there are a ton of other interesting things that we can do with software security instrumentation. For instance, we can automatically add defenses to applications. Right now, if you want to add, I don't know, access control or input validation or encryption to an application, your development team has to go write that stuff and implement it in the application. What if we could weave it into the application automatically? What if the instrumentation could identify, hey, this is sensitive data coming in. We need to encrypt that before it goes into any storage. Well, that's the kind of rule that we can automate. And then notice we're not relying on developers to do that. We've got automation that works every time. So we're consistently applying these security controls. We do the same thing with access control. Maybe you want to make sure every API has an access control check. Well, why not weave it in as opposed to relying on development to code it in? Access control is probably the least tested area of security. That's where, I specialized in that. I love testing access control schemes because they're always broken, because everyone writes their own custom access control scheme in every single application. And nobody can get it right, but automation can get it right. So we can do these things. We can add defenses. We could actually harden or enable existing defenses. Many of the platforms that people are using have defenses built in for things like CSRF and, verb tampering and so on. We could enable those in applications that don't have them. The instrumentation could just turn them on. We could, anybody done like threat modeling or architecture review? Did you get a pile of PDF papers from like 5 years ago that don't match the system at all? We could automatically generate that kind of diagrams and information directly from the running application. We do a little bit of this today, and it's terrifying, the back-end connections that applications make. There's always a surprise there. It's reaching out to some internet system. There's always connections that the development team has no idea are there. We can do that automatically. We could even use instrumentation to dynamically adjust the security level of an application. Like, hey, what if all of a sudden we notice some attacks coming in and we want to switch to like DEFCON 3? And now, while you're in DEFCON 3, people have to go through an extra authentication step before they can perform a transaction, to step up authentication kind of rules. We can do that kind of thing automatically with instrumentation, all without changing a single line of code. We can weave it into applications automatically. So this is not all about technology. Some of this is about how do we get development and security working together productively. And you can say, well, it's, culture is the most important thing or process is the most important thing, but frankly, they're all tied together, people, process, and technology. And if you've got better technology, your processes and people aspects can be different. They can change. And so, to me, instrumentation is really a platform that allows development and security to work together productively in a way that they don't work together productively now at all. Most of the organizations I go into, security teams have a lot of trouble getting things done, and there's friction with development teams who just want to push out code. And we've got a very negative culture around security. But if you show up with instrumentation to development teams and say, hey, just do this little thing, add this little agent to your applications, and then you're in control of security. And as long as you're clean, as long as you don't have custom code vulnerabilities, as long as you don't have libraries with known vulnerabilities, as long as your testing shows that you've got good coverage over the application, then you're cleared to go into production at whatever velocity you want to go. They'll be like, yes, thank you for coming. I love you, security. And that's not the way it works today. So really, I believe that in order to harmonize development and security, we've got to use different technology. Sometimes giving people shovels just isn't enough. You've got to come with a bulldozer. So that's the kind of change that I want to see. If you want to try it, we've made a version of IaaS, RASP, and DSCA free for anybody. It's totally full strength. It's not time limited. It's just for one application. And we're trying to empower all the little companies in the world that will never be able to afford expensive application security tools. we want them to use this technology to protect themselves, because we can raise the bar for the other 94% of developers in the world that don't have access to all the products that are in the other room. We're making it free for them so they can raise the bar on security. It's for Java and .NET right now, but very soon we'll be releasing Node and Python and Ruby as well. So with that, I'll stop. We got a few minutes for questions if anybody has any. Yeah.
So what about serverless architecture?
Oh yeah, it's a great question. So serverless platforms don't yet have a good instrumentation API. We're working really hard to figure out the best way to instrument serverless apps, and our goal is to be there before serverless gets really huge. But it's still kind of an R&D area right now. But ultimately, I believe that all software in the world will be instrumented for security. It's crazy to me that it's not, actually. But whether it's software that's in your car or your blender or the space shuttle or whatever, it needs to be instrumented so we can see what's going on in there. So it'll be there. It comes with a really large set of built-in rules. Like if you imagine like kind of all the things that SAST can do and all the things that DAST can do, we're a superset of that. But I feel pretty strongly that you should be able to add custom rules, because most of what comes with tools are what I call negative rules. They detect behavior in an application that should never happen. It's much more assurance if you say, this is the only way that we access the database in this, or this is the only way that we should do an access control check. And so, enabling those positive rules is part of it, yeah. But I'll tell you this, most people don't build custom rules. Whether they're for dynamic tools or static tools or contrast, most people don't do it. I think until you dig out from that backlog of security vulnerabilities that you got piled up in the corner, then it doesn't make a ton of sense to start raising the bar and doing more custom things, at least for most organizations. The good news is that instrumentation is a really good match for APIs and microservices, where static and dynamic tools really flounder for a variety of reasons that I'd be happy to go into, but they don't work very well on those technologies. But for instrumentation, it works naturally, because we just see it from the inside. It looks a lot like any other kind of app. Yeah. Look, I love AI. I tried to major in AI in college many years ago, but it's not really appropriate for this set of problems, and I'll tell you why. For the things that we know about, like we've known about SQL injection for 25 years, XSS and CSRF and all those things, they're well understood. We know exactly the pattern of behavior that we want to prevent, and so for those things, AI is dumb, because it's much better to write a rule that we absolutely crystal clear understand, rather than training some ML thing that we don't really understand how it works, right? So that's for things that we know. But you might say, hey, why don't we use AI for the shit we don't know about? New attacks and stuff. The problem there is there's no data set. Every application security attack looks different from the stuff that came before. And if you want to have AI, you got to have a big data set to train the AI to identify it. And we don't have that for new stuff. So that leaves you in this weird no man's land where AI isn't good for stuff that we know about, and it's not good for stuff we don't know about. So to me, it's like, screw it. I'm sorry, it's like a solution looking for a problem. So there's not that much mystery. I mean, there's like maybe one new class of security attacks, security vulnerabilities that comes out every year. And it's better to just study it and figure out what is the exact rule that we want to prevent. It's the further you get away from the code and the data, the more AI sounds like a good idea, because it's much messier. Like if you're in a WAF, all of a sudden, maybe it's like, well, we can't write a crystal clear rule, so we'll just write this fuzzy rule that tries to approximate good, but it's never going to work. Yeah. All right, well, I think I'm out of time. Thank you very much. There's a booth out there. I'm going to be standing there for a while, so please come talk to me. Thanks.